look at one of my most favorite contracts, the Morpho Blue contract. Morpho, as you probably know, I hope you know, is the second biggest lending protocol behind Aave. But what's beautiful about Morpho is you can create new markets permissionlessly, and we're gonna look at how they do that. So yeah, let's just open up the contract. It's a very small contract, which is great. It's just 550 lines of code with a lot of empty new lines in there. So very nice. This is very beautiful. Okay. So what's the magic? Where does the magic happen here? It's inside create market. Okay. So anyone can call create market, and create market takes a couple of parameters, which are defined in market params. It's also very cool how they set up the structure of the contracts with the interfaces, with the libraries, and so on and so forth. There are also no external imports here. So for example, IRC20, it's actually interesting, it's empty. It's empty because we only call library functions, which I'm calling instead of safe transfer, I see. So if you go into here, this is probably, I don't think they've written this from you could have reused that from Soulmate, but they decided to implement everything from scratch, basically without any outside dependencies, which is definitely an interesting take. Okay, so let's go back, function create market, and create market takes market params. So market params takes 5 things: the loan token, the collateral token, the oracle. IRM is the interest rate model, and LTV is loan to value. And let's discuss what all of this means. So we have the loan token, we have the collat token, we have the oracle, interest rate model, and we have the loan to value ratio. Okay, LLTV. So okay, let's say you want to create a new lending market. What does that mean? So a lending market has a loan token, okay, which you're actually going to borrow, and the collateral token that you're going to put in as collateral. So let's say we have a loan token. The loan token is USDC, and we have a collateral token, which is ETH, and we have the oracle is the Chainlink, ETH, USDC oracle. And the interest rate model, and it's actually I could do a whole nother video about this, but the interest rate model is decides or calculates how much interest you're going to charge to borrow. And it's based on a utilization rate, which means how much of the loan tokens are taken out of the pool. And loan to value ratio defines how much you can borrow. So let's say the loan to value ratio is 80%. That means you can put down $100 worth of ETH, and you can borrow up to $80 in USDC. This is the loan to value ratio. Okay, so what's interesting about this? There are a couple of interesting things here. So one thing is, if you look into create market, you can see it's checking a couple of things. So the first thing is it checks, is the interest rate module or interest rate model enabled? And this has to be approved by governance, by the Morpho governance. And currently there's only one. So if we look into Morpho interest rate model, it's gonna tell us the only interest rate module or model that has been governance approved is the adaptive curve IRM. This is the only one you can use, okay? And they go into a lot of detail and describe that. The other one is the loan to value ratio has also needs to be enabled by governance. So if we look at Morpho loan to value, I also already looked at this. They have a couple of ratios approved by governance. So let's see, I think it's maybe in the interface. Morpho create market. Is it defined here? LLTV? It's not, but let's do something. Morpho blue contract address. Let's look at it on chain. So we have also look at how many chains. Not deterministic. Apparently they didn't use create to. Interesting. So they have different addresses for different chain. But let's look at Morpho blue. Okay. So Morpho blue, if we look at, let's see, where is LLTV enabled? So it has to be, is LLTV enabled? Enable LLTV shows an event, which goes enable LLTV. So we should be able to filter by that. We don't. Doesn't show up here for some reason. Let's see, maybe it's under advanced search. Enable LLTV. Okay. So interesting. These are all the LLTVs that got governance approved, and they were all set when the contracts were deployed. So if we look at these, we can see all the loan to value ratios, and you can find that in the docs, of course, but I think this is interesting. You can see all of them. So this is 62%. This is 38.5%, 91%, 86%, and so on and so forth. I think the lowest one is like 33% and the highest like 99%. So yeah, Morpho in general is permissionless. You can create a market, but you cannot choose your own interest rate model, and you cannot choose your own loan to value ratio, which is an interesting decision that I don't fully get, because markets are completely isolated. So if one market blows up because the loan to value ratio was set too low and the collateral was some meme coin, very volatile, and the market gets destroyed, the markets are isolated. So you could make that an arbitrary end, in my opinion. Maybe they decided against it because of reputation risk. Like they don't want some weird pool to blow up as like, Morpho protocol got exploited or something, which wouldn't be true, but it's like a reputation hit, I guess. Okay. So let's create market. We check last update, we set last update, and then we throw an event. Also interesting, they don't put, I always put events in an interface. They put it in an event library, which I think is kind of clean. So they have all the events in events lib. It's under libraries. There's all errors are inside an errors lib, and so on and so forth. So they generate how they check that the market has to be unique, right? So how they do that is market params. There is a market params library using market params lib for market params, and market params lib has all these structs, but also has the this is the interface. So we're looking for the library ID here. We hash market params, and this is how we get the ID. And the ID has to be unique. Okay. It's also beautiful, like just forge build. I just cloned this, right? Just works. It's very nice. Other than that, which is interesting, I don't see the deployment scripts in here. I don't see a deployment script. Deploy, this is base. I don't see, I don't see the deployment script. So they have deployment script. They have the tests in here. Tests, these are all the tests. Forge and Helm's tests. But they don't have the deployment scripts in here, which is kind of interesting. Okay. So looking at the storage variables, also I like these. I kind of like the comments, like immutable, storage, constructor, modifiers, and so on and so forth. Also, if we look at, I always like to look at who actually built this thing. So cool. Very interesting. There's a fee recipient here. Fee recipient is set by the owner. Set fee recipient, own the owner, and they can enable fees on any arbitrary market if they decide to do so, which is interesting. It's like they have a global fee switch for all markets on Morpho that they could enable. Obviously, they cap it. So if we look at set fee recipient, actually there is no cap. No. Could be 100%. So normally what you check here, check against a max fee value. It's kind of best practice. Oh, that's the recipient. Oh, here, max fee exceeded. Exactly, max fee, set fee. There you go. 25%. Yes, okay. Also, again, they do this for errors, they do this for events, they do this for constant as well. They put a constant inside the libs. It's kind of clean. Okay. So let's look at the storage. You have an owner, you have a fee recipient, you have a position. Also, I like the abstraction of an ID. ID is just a wrapper around byte 32, but it's way cleaner to read. You have an ID to a market. Market stores a couple of things. You have the check is an interest rate model enabled, and interest rate model is just another contract. So if we look at, let's close these. If we look at the, what is it called again? Adaptive curve, GitHub, Morpho Blue. So they have an interest rate model, a repository. And inside there, you have the adaptive curve. They also implemented the fixed rate. but that never got approved by governance. So look at Morpho again, and we look at the contract. No, if we look at transactions, if we look at advanced filters, if we look at interest rate model enabled, where is it set? It's set here, and it throws enable IRM. So if we search for that, enable IRM, again, 720 days ago, this was called shortly after deployment. First of all, this one sets this address, and this address, this is the adaptive curve, IRM, right? So this is what we're looking at right here. This is what they talk about in the docs. So this is the first one, and the second one, let's see, is the zero address, okay? So the zero address is a valid, so actually they have two kinds of interest rate models, adaptive curve and no interest at all, if you're interested in that. Okay. So then we have a nonce, which is for some signature stuff, I guess. The main signature, and this checks against the nonce, yes. It's for a replay protection. And then you have ID to market params, which is literally just storing the params on chain when you create a market. So is authorized, okay, so is also authorized is a system they have inside of here. Also, interesting decision. Some people do that, some people don't. It allows you to give someone else permissions to call things inside the Morpho contract on your behalf. I think you can solve that through account abstraction stuff, but they decided to hard code that or do it in the contract itself. You can do that. Okay, so that's the storage. Constructor, very simple, sets the owner, and you already have the set fee, which takes. Okay, so also interesting choice that they do here is, instead of passing an ID, like they could pass in the ID of the market, they decide to, and this is going to be annoying for front-end people, because front-end people are going to have to make sure that they actually pass in the full market params struct in here. So every function takes a market params instead of an ID. Like you could, theoretically, you could do this, right? ID. And then instead of doing this, you just do this. But they set against that. They pass in the market params and then they calculate the ID on the fly. Okay. So set fee, create market. We talked about create market. And then, okay, we have the lending market specific functions. So we have supply, we have withdraw, we have borrow, we have repay, we have supply collateral, we have withdraw collateral, we have liquidate. Okay, so I don't want to get into too much detail about each function, but supply is, if we look at the Excalibur, if we have a USDC ETH market, so you put down ETH to borrow USDC, you would supply is, in this case, supply USDC. Withdraw is withdraw USDC. Borrow would be borrow USDC. Repay would be you would call repay to repay sum of what you borrowed. Supply collateral would be supply ETH. Withdraw collateral would be withdrawing ETH as well. So what I like about these functions are they are very symmetrical. So first of all, you always have the market params ID calculation. Okay, it's just beautiful. Like it's nice to read symmetrical code. So you have the ID calculation every time, and then you have a bunch of requires, and they do that for every function, which is great. After the requires, you have the accrue interest. Accrue interest. Require accrue interest. Require accrue interest. No accrue interest here because, see, that's, I love these details. You would expect an accrue interest here, right? And the person that wrote this was aware of this. And he's like, don't accrue interest, it's not required and it saves gas. Beautiful stuff. Require accrue interest. Okay. So the other thing that you check is healthy. We have an is healthy function. And the is healthy function is if you have a loan to value ratio of 80%, you basically check if it's under 80%, it's healthy. If it's over 80%, it's not healthy, and you can get liquidated. And liquidating someone means, if this is a USDC ETH pool, it would be, I repay some of the USDC and get all your collateral, or some of the collateral. They have partial liquidations. That's how liquidation works. The other thing that is interesting here is the design space for liquidations. Interesting. Probably, yeah. I don't like the. I think the new Forge linter things should be off by default. I'm not sure. So the design space around liquidation is very big. Most protocols implement liquidations differently. Some have like fully liquidations, from others have partial liquidations, all that kind of stuff. But here they force you to use this one liquidation. If you would do Morpho V3 or something, because they're working on V2, maybe make this more flexible. Have like a contract that where you can implement a custom liquidation function, or a contract that gets approved by governance, just like you do on the interest rate models. And to be honest with you, this is most of the contract. You have a flash loan. You can flash loan everything inside the pool for a zero fee. You have the authorization process to give access to someone else on your behalf. You have the accrue interest. If you're interested in the math, go deeper into this. I think describing the math in the video is always tough. Also, this is cool. This is interesting. I don't know about. I've seen this a couple of times now. It gives you arbitrary read and storage slots, which, fair enough if you need that on chain. Off chain, obviously, you can just look up the storage slot, but this is for other contracts to call into it. It's a shorter way of, you could like write a bunch of view functions in here, which is kind of ugly. So they just have, hey, put in the storage slots and we return what's there. And you can interpret that as you want to. It saves you a ton of view functions, I guess, which is kind of cool. Actually, it would be interesting to read about this in the iMorpho base. Where's the interface? iMorpho base? iMorpho base? There is no iMorpho base. Is it in here? Returns the data stored on different storage slots. iMorpho base. Oh, it's inside iMorpho. Okay. They have a couple of interfaces in the same file. Cool. Another thing I want to talk about is, so first of all, okay, so we have, I don't want to butcher your name, we have Merlin, we have this guy, we have Mattis. Yeah, great work on this. Also, I love this. I always have the audits in the repo. A big fan of this. What's also cool is they have Certora, the Foundry, and Halmos CI scripts in here. So on every pull request, I guess, every pull request into main, they run a bunch of Certora things. I've never played around with this, but this is really cool, I guess. No, it's great. It's great. You have your Foundry stuff, your fuzz test, your invariant test. You have your Halmos tests. This is very cool. Now they take security very, very seriously. You can also see this is not only on Morpho Blue, but it's all the contracts, all the audits they've ever done. I also love this. The article. They have an article about how they do security. Must read. Read this. If you're into smart contracts, read this. It's great. I actually read this like a year and a half ago, but I remember this. I don't know, when did I? Yeah, it's a bit old. This is fantastic by Merlin. Great stuff. So yeah, in general, very, very clean. I also make fun. Very, very clean. I'm a big fan of the Morpho contracts. You know, I have this GitHub repo where I have my favorite smart contracts, and wait, there's here. Jeez. Okay, let's change that. Yeah, that's crazy. So let's do Morpho lending. Let's get the contracts, Morpho lending, this guy. What? GitHub. Why is it doing this? What? Morpho Blue. Well, I can link the video after uploading this. So this is okay, and then we have Morpho docs, which we're gonna link as well. This is kind of crazy that I've never had this here. Yeah, one of my favorite contracts for sure. So this looks about right. Let's double check. Morpho lending. Oh, I messed it up. Morpho Okay, like this. Like this. Morpho landing. Okay, great. Yeah, sorry about doing that in the video. But awesome. Okay. Morpho, great. So yeah, fantastic. Look at it. This is Morpho. Morpho Blue. Also, okay, so if we look at so what's great is, okay, create market, isolated market on top of Morpho. So you have a set of markets. And so if you look at app.morpho, what you can see is you have these vaults. And the vault has a set of Morpho Blue lending markets. So if you look at the stakehouse, you have the USDC CBTC market, you have the USDC Rep BTC market, you have the USDC Rep staked ETH market, and so on and so forth. And this gives you an aggregated APY. And this is curated by a curator. Okay, so in this case, it's Stakehouse Financial. So this is how it works. Like if you look at a vault is an aggregation of Morpho Blue markets, and these are created through. Look at the Morpho org. It's Metamorpho. So Metamorpho is used to create these markets these vaults that you see. Create Metamorpho. And Metamorpho is a vault, 4626, expect that. And this is where you have the curators, the allocators, and guardians, and so forth, so on and so forth. Maybe looked into that in another video. But yeah, on Blue, I hope you enjoyed this. Take a look at the contracts yourself. Next step would be actually go through the math. Look at this is very, very nice symmetry. Obviously needs some shuffle formatting, but yeah, great stuff. Thanks for tuning in, guys.